Welcome to the Ultimate Beginner's Crash Course on Python. Programming is one of the most powerful skills in the modern world, giving you the power to automate boring tasks, analyze complex data, build intelligent AI models, and design beautiful web applications from scratch. But what exactly is a programming language? At its core, programming is simply the art of writing a series of step-by-step instructions that a computer can understand and execute. Today, you will learn Python, the world's most popular and beginner-friendly programming language. Together, we will master variables, data types, conditionals, loops, functions, and object-oriented programming. Don't worry if you have never written a single line of code before. We will go step by step, explaining the core mechanical logic behind every single concept. Let us begin our grand journey into the heart of computer science.
Created by Guido van Rossum in 1991, Python was intentionally designed to be highly readable, elegant, and extremely simple to write. Unlike other traditional languages that require complex symbols and repetitive boilerplate code, Python's clean syntax reads almost exactly like plain English. This elegant design allows you to spend your precious time solving problems rather than fighting with the spelling and structural rules of the language. Today, Python is the absolute gold standard in artificial intelligence, machine learning, data analytics, web development, and scientific research. Companies like Google, Netflix, NASA, and Spotify rely heavily on Python to power their core recommendation engines and back-end services. By choosing Python, you are opening up an infinite world of creative and professional opportunities.
We begin our programming journey with variables, the fundamental building blocks of all computer programs. Imagine you are moving into a new house. You wouldn't just throw all of your clothes, books, and kitchen plates into a giant, messy pile on the floor. Instead, you would pack them into distinct cardboard storage boxes, write a clear label on the outside of each box, and stack them neatly on your shelves. In computer programming, a variable is exactly like one of these cardboard storage boxes. It is a reserved space in your computer's temporary memory that holds some data. By giving the box a unique name or label, we can store a value inside it, retrieve that value later, or change the value whenever our program needs to.
Let us see how easily we can create and manipulate variables in actual Python code. Look at this educational code sample: age equals 25 and name equals Alice. In Python, we create a variable by writing the variable's name, followed by a single equals sign, and then the value we want to store. The single equals sign is called the assignment operator. It tells Python to take the value on the right-hand side and stuff it inside the storage box on the left-hand side. In our code, we have created a box labeled age storing the number 25, and a box labeled name storing the text Alice. Later in the script, we can print these variables to the screen or even perform math on them, like adding 1 to our age.
It is time for your first interactive practice quiz. Look closely at the Python code displayed on your screen. If we run x equals 10, then y equals 5, and finally x equals y, what will be the final value stored inside the variable x? I am going to give you exactly 5 seconds to analyze the code. Keep your eyes on the circular progress bar in the center of the screen as it counts down, and try to find the correct value before the timer reaches 0. Good luck, your 5 seconds begin right now.
Now that we know how variables store information, let us talk about the different kinds of information we can store inside them. These are called data types. Just like a real storage box might hold a number, a piece of text, or a simple yes or no answer, Python variables can store distinct data types. First, we have integers, which represent whole numbers with no decimal points, like 42 or -7. Second, we have floats, short for floating point numbers, which represent numbers with decimal precision, like 3.14. Third, we have strings, which represent plain textual data, and are always enclosed inside matching single or double quotation marks.
Beyond numbers and text, Python has 2 more fundamental primitive data types. First is the Boolean type, which represents simple logical values, true or false. Named after mathematician George Boole, Booleans are the binary decision makers of programming, representing states like light on or off, logged in or logged out. Second is the none type, which represents the deliberate absence of any value. Think of none as an empty cardboard box. It exists, but there is absolutely nothing inside it yet. It is a highly useful placeholder when you want to create a variable but wait to assign its real content later in the execution of your program.
What happens when we want to store multiple items together under a single label? This is where Python's built-in collection data types shine, beginning with lists. A list is an ordered, mutable sequence of items wrapped in square brackets and separated by commas. Imagine a multi-slot pill organizer or a chest of drawers. Each drawer has a numerical index, starting from 0. In this list, fruits equals apple, banana, cherry. Apple is at index 0, banana is at index 1, and cherry is at index 2. Because lists are mutable, we can easily add new items, remove existing ones, or reorder the items at any time during our program's execution.
The next incredibly powerful collection type is the dictionary. Unlike a list where items are found by their numerical position, a dictionary stores data in associated key-value pairs, wrapped in curly braces. Think of a physical, real-world language dictionary. You don't look up a word by its page number, instead, you look up a specific keyword to find its value definition. In Python, dictionaries function exactly the same way. For example, user equals name, Alice, age, 25, stores the value Alice under the key name, and the number 25 under the key age. This key-value design provides rapid data lookup and highly readable code.
A computer program that simply executes the same instructions in a straight line would be very boring and rigid. To make our programs smart, they must make decisions based on real-world conditions. This is where conditional statements come in, functioning exactly like a fork in a hiking trail. In Python, we use if, elif, short for elsif, and else statements to control the flow of execution. For example, if you check your bank balance and have enough money, you buy the coffee, otherwise, you go home empty-handed. By evaluating conditions to true or false, our code dynamically chooses which path to follow, making our software intelligent and highly adaptive.
What if we want to perform the exact same action 100 times? Typing the same code over and over is exhausting, messy, and error-prone. This is why we use loops, the automation superweapons of programming. First, we explore the for loop, which is designed to iterate, or cycle, over a predetermined collection of items, like a list. Imagine a runner running around a circular sports track. Every loop represents one item in the list. In Python, we write for fruit in fruits.
The second type of loop is the while loop. Unlike a for loop that runs a set number of times, a while loop keeps repeating its code block endlessly, as long as a specified condition remains true. Imagine driving a bumper car inside an arena. You keep driving forward while your front bumper has not crashed into a wall. The moment your bumper hits a wall, the condition becomes false and you immediately stop driving. While loops are extremely useful when you do not know in advance exactly how many times you will need to repeat an action, but you must be careful to avoid infinite loops that crash your computer.
Let us test your understanding of Python loops. Look closely at the code on your screen. Count equals 1, while count less than 4, print count, and count equals count plus 1. How many times will the loop print to the screen? This is a fundamental dry run trace that every programmer must master. Watch the circular countdown timer shrink in the center of the screen, analyze the loop's counting logic carefully, and identify the correct number of prints before the 5 seconds run out. Your time starts now.
As our programs grow in size, writing all of our code in one long, continuous script becomes extremely messy and impossible to manage. To solve this, we use functions. A function is a reusable block of organized, self-contained code that performs a single, specific task. Think of a function as a magical factory machine. You feed raw materials, called input parameters, into the machine on the left, the gears turn inside to process the materials, and a shiny, completed product, called the return value, pops out of the machine on the right. By wrapping our code inside a function with the def keyword, we can run that complex block of code anywhere in our script with a single line.
Finally, we explore object-oriented programming, or OOP, which is a powerful way to structure your code to model the real physical world. Imagine you are a factory engineer. You first create a blueprint that defines the structure and behavior of a car. This blueprint is called a class in Python. Then, using that blueprint, you can manufacture hundreds of actual, physical cars. Each individual car is called an object or an instance. In Python, a class defines the shared attributes, like color and model, and behaviors, called methods, like accelerate and brake, that all objects created from that blueprint will possess.
Congratulations! You have successfully completed this Python crash course for beginners. In just 30 minutes, you have mastered the fundamental mechanics of variables, data types, lists, dictionaries, conditionals, loops, functions, and object-oriented blueprints. You now possess the foundational logical keys to unlock the infinite world of coding. The secret to becoming a master software engineer is consistent practice. Start small. Write a simple script to automate your spreadsheets, build a basic terminal-based game, or explore a library like Pygame. The code you write today is the seed for the extraordinary innovations you will build tomorrow. Keep coding, stay incredibly curious, and thank you for joining our masterclass.